Good evening, guys. A warm welcome from Databricks. Thank you all for coming to the first Bay Area MLflow inaugural meeting. Delighted to hear so many of you are here today. As you know, how many of you actually attended Spark's AI Summit a couple of weeks ago? Brilliant. We introduced our open source platform by Mate, an open source platform to do machine learning at scale. And we wanted to actually get the community started contributing to it because we know that the community is where things actually happen. We believe that innovation actually happens in collaboration, not necessarily in isolation. So it was important for us to share some more technical details on how you guys as developers actually can get started. And to kick off today, we actually have members of our ML team. Are the members of ML team over here? Can you guys raise your hand? There you go. These are the members of the contributors on the ML team. And to kick off our first speaker, we have Matej Zaharia. He's a man who needs no introduction, but I'm going to introduce him anyway because the words taste like honey in my mouth. He is the original creator of Apache Spark. He's also created MLflow. He is the co-founder and chief technologist here at Databricks, and he's also a professor of computer science at Stanford University. So without any further ado, please give a warm welcome to Matej Zaharia.
All right, thanks. Yeah, so the plan for today is I'm going to give a few slides on the MLflow platform and also the design philosophy behind it to get people to know, where we're coming from here. And it is still an alpha software project, so we love input into any of these pieces. And if people try it out, I'm sure you'll have a lot of ideas to make it better. And then Aaron Davidson, who's one of the engineers on the team, is going to show you a sort of getting started tutorial and demo for how to set this up, how to launch a server, and how to use MLflow. And we also have most of the other members of the team here, so I think they'll be happy to talk. Some of them have MLflow t-shirts, so they'll be easy to find. We don't have any more t-shirts though. So sorry about that. So here's the outline. So basically, we'll talk about some of the development challenges in machine learning that MLflow tackles, how we tackle these, and demo it. And then I'll also talk a little bit about a future roadmap that we have at the end and how to contribute to the project. So I think everyone who tries to do machine learning development discovers that it's pretty complex. And I just want to briefly talk about some of the problems that we're tackling here and to introduce the other components. So this is kind of your typical ML lifecycle. You've got your data, you do data preparation, training, then deployment, and then you often generate a lot more data as well, all your predictions, and you want to diagnose those or use them back as input. So there are a few key reasons why this is challenging that we're trying to tackle here. So the first reason is just that there are lots of different software frameworks involved for pretty much every step. Many types of storage, many types of libraries for pre-processing and for training and so on. And the interesting thing about this is, unlike in normal software development where you pick, say, one framework for your front end and one for your server, here you often want to use all of them because your job is just to create a really good model. So you want to try every algorithm you can find, you want to try every featureization tool and so on. So you actually have to deal with many of these things. So this is kind of first challenge, lots of tools. Second challenge is tuning. Some of these have parameters. You need to remember which ones you used. That can get pretty hard. Then there's scale. All of these things need to happen at large scale if you want to use all the data you have available, which often leads to a better result. Then there's model exchange. So as you move your models and artifacts that you produce between these tools, there's often no standard format to pass it between them. And if you have different teams working on it, like a data science team and data engineering team, that also creates further friction because they might not understand what exactly they're passing back and forth. And then the final issue we have is governance. So when you go back and you want to audit, for example, what data went into this model, it may be difficult to do unless you maintain a certain discipline as you were developing it. So this is kind of the summary of the issues you want to tackle. Lots of software tools, hard to track and reproduce results because there are many inputs, how to productionize, and then all of these things should be able to run at large scale to get good results. So MLflow is this new open source project we launched, which is designed to be an open machine learning platform. So it's inspired by the kind of machine learning platforms that many companies build internally when they get to a certain scale. You know, you have a team whose job it is to build a platform and make it easy to deploy stuff, train stuff, and so on. But it's designed to be open in the sense that it's open source, and also you can use whatever libraries and whatever languages and so on you want in the process. So you don't need that single team building the platform to have to bless and support every tool that you want to use. So it's designed to work with any ML library and language, and to run the same way anywhere. So for example, you can use MLflow to submit jobs to Amazon Web Services or Azure or Google Cloud, and you don't have to pick a specific one. And it's also designed to scale in terms of number of people. So we tried pretty hard to figure out, you know, because what would be useful even for a single engineer or data scientist working alone that would cause them to use this for their day-to-day work, and then they would get the benefit of having a shared platform within the team. Because often the problem with telling people, okay, you have to work in this way to make the result well documented, is that it creates overhead for them. So we tried our best to do this. I'm sure it's possible to do even better, but it's definitely, you know, something that a lot of individual users feel that can improve just their workflow. So I'll talk a little bit to show how we achieve these things. I'll talk a little bit about kind of the driving design philosophy, and then I'll dive into sort of the components that come with the platform. So when we designed this project, we actually thought a bunch about how it should look. There's many different kind of trade-offs in terms of how to build it. And we picked two main things to be the driving philosophy. So the first thing is what I mentioned a little bit before, which is that it's an API-first open platform. So what that means is anywhere you can run code, you can submit results to MLflow, submit models and have them be used by future tools, and submit projects that other developers can run. So we're not telling you to use a specific ML library or even a specific programming language. And so that means you can naturally integrate it into different tools. So just as an example of this, one place this comes up is actually model deployment. So there are many different model packaging formats out there that often work with just specific tools. Like there's the Onyx format for deep learning that works with PyTorch and Caffe. There's the TensorFlow format. There's PMML, which is sort of an old school format for that, you know, various existing tools can use and so on. But what we realized is a lot of the deployment tools, they don't actually care about the internals of the model, like what weights are in there and so on. They just want to apply it to some data. So for example, in MLflow, one of the supported formats is just a Lambda function, so a Python function. And anything that can run Python can then apply your model. And so for example, if you export a model in this form, you can run it as a web service in a Docker container. You can deploy it to cloud serving platforms like Azure ML. You can actually use it as a user-defined function in Spark and use it in a batch job or a streaming job and so on. So this is just one example of what I mean by API first. It's what operations are you trying to do with the thing, and then we'll put it in a box and let you do those operations with it. So that's kind of the first element of it. And the key enabler for this is that we built everything around REST APIs and sometimes command line interfaces that you can easily call from and use with any library. And then the second element is having a modular design. So we realized that coming up with a monolithic platform and telling everyone, well, you have to do everything this way can be a non-starter for many people, because many teams already have some kind of workflow in place around machine learning. So we've divided MLflow into components that you can use individually, and that makes it easy to try out some of the components when they make sense for your workflow. So for example, one of the components in MLflow is this way of declaring projects where you can say what dependencies your project has and what parameters and so on, and then other people can call it and tweak the parameters without knowing the details of your code. And if you want, you can use just that piece. You don't have to use our deployment tools or even our experiment tracking. And same thing with the other pieces. Maybe you've already got some awesome experiment tracking, but you would like a way to save and manage and deploy models. You can use just that piece. So what's nice about this is it's easy to integrate this into whatever workflow you have and use it incrementally, and not all of it has to be perfect. So we're not trying to force you to switch to whatever you're doing. So the key enabler for this is having these distinct components, and they're designed to work well together, of course, but they're also designed so each of them brings something on its own. Okay. So that's enough kind of, I guess the final thing I want to talk is why open source. So why did we make it open source? So it's kind of two reasons. So first reason is everyone working on machine learning is solving a similar problem. It's not really different at different companies. So we felt that people can team together to solve this problem. And then the second reason, which is quite interesting, is that there are many benefits for ML users and the ecosystem in general in having common APIs around some of these things like projects and model management and so on. So for example, let's say your company develops some interesting ML algorithm and they're actually willing to open source it. And it's something that you want other people to try to use. Well, if you open source it as an MLflow project, anyone else can run it just using a little shell command, and they can pass in data, and it's very easy to install. And you can share workflows not just within a company, but you can take these projects that exist in the ecosystem. Another example is if you're developing machine learning tools. So for example, maybe you've got an awesome new deep learning library, and it's really great. You're really good at creating a nice API for it, but you don't want to write a serving tool. Again, if you use the MLflow model format, which can be as simple as a Python function, we will handle the deployment to all kinds of different places where people want to do inference. And the same is true if you build a serving tool. You might have the best serving tool ever, but you don't want to go and integrate with every ML library. So we think having this this option for kind of a common interface that lets you combine all these tools is quite powerful. And we were also inspired here by a lot of the kind of package management system that often exists within, say, a single programming language. Like, for example, if you're developing stuff in JavaScript, you can get so many different tools that work well together through NPM. You can just load a tool from GitHub or publish your favorite component, and other people can use it. And we found there's nothing like it for machine learning that people can use. Okay, so that's kind of enough about the philosophy. The next thing I want to go into is just the components of the project, and I'll briefly introduce them, and then Aaron will talk about the specific ones. So there's three components in this kind of alpha release that we have out now, and we're going to add more of them in the future. But this is kind of enough to give you a sense of the kind of platform we want to build. So the first component is called tracking, and the problem here is how to record and query experiments that you ran. So what code, data, config parameters, and results went into each experiment. So this is a common problem that we found even an individual person working on machine learning on their own has this problem. And then in a larger organization, it just becomes a bigger one of how do you get the same result again? And so we built this server and API that lets you easily manage this. The second component is projects, which is a packaging format for reproducible runs. So if you package your project this way, we know how to run it in different environments. Of course, if you report results to the tracking API, we'll also log that. But you don't have to use this format. You can use tracking on its own, or you can use projects on its own without the other stuff if you want. And then the third one is models, which is this pretty general model format that can support different deployment tools. Actually, the same model, you can view it in multiple what we call flavors that can be handled by different tools. So I'll explain a bit what that looks like. That's probably the weirdest one compared to existing stuff. Okay. So just to dive into them, I'm just going to show kind of a picture and overview of each one. So the tracking component, the idea is wherever you're running code, could be anything, could be a notebook, could be cloud job, could be a local application on your laptop, you can use the REST API or a Python API to report results to a tracking server. And then you can visualize the results. You can share them in your team, maybe have something like a leaderboard where different people are trying to solve the same problem. And if you want, you can also query them through the API, so analyze them automatically. We found it's very easy to get hundreds of runs, even in a few hours of working on a problem. So it's really nice to have something that actually remembers all of them and tracks them for you. And actually even querying them then becomes kind of a big data problem. So with tracking, again, Aaron will demonstrate this, but there's basically 4 different things that you can log. And then you get this server and this API to view them. So you can log parameters. These are just key value pairs that you want to pass to your code. Like, for example, what is my training data file, or what is my regularization parameter? They can just be any string you want. You can report metrics, which are numeric values, and then the interface can sort things by these and search by these. And you can also update them over time. So you can see in real time as your model is training what the metric has become. You can also report artifacts, which are just arbitrary files. For example, if you save a model, it's just a file. And then finally, we remember what source submitted the project. So a source is something like the program you ran, or if you're using MLflow projects, it's actually, we remember the reference to the project and its Git commit and stuff like that. So these are kind of the main concepts, and you get this UI to see them. I think you'll see it when Aaron shows it. The second piece is projects. So the goal here is pretty simple. We want you to have a little spec that says what you need to provide in order to run a certain step of your workflow. And it can contain code, it can contain configuration, like what parameters it has. You can even include data in your project if there's a data file that it needs. And then we can run this in multiple environments. So we could run it locally on your laptop, you could run it on a remote execution platform. It's just a command to run it, whatever environment you're in. If you've got Linux in there, you can actually run this project. So what do these look like? So each project is simply a directory. You can store it in Git if you want, and MLflow knows about Git and can remember versions and stuff like that. And basically, you've got all the files needed for your project, and you've also got this ML project file, which is a little descriptor file that says what is needed to run it. So in the ML project file, you can declare dependencies. Right now, we use Conda for Python dependencies, as well as native libraries. And you can also declare entry points that people can call. So an entry point being an application within your project. And for those entry points, you can also declare parameters. So the nice thing about this is if you're running someone's project, you don't need to know, like, okay, they use Python and it takes arguments in this order or that order, and I need to install, TensorFlow 1.6 to run it. You can just use a command, MLflow run, and pass in a URI of the project, and we'll set up an environment and execute it. And you're kind of agnostic to what's inside there. And then the other nice thing about projects is you can also run them programmatically, and you can actually write, like, say, a notebook that executes a workflow consisting of many projects using this MLflow.run. And if you want to submit them to a remote execution platform, then you can even run lots of experiments in parallel and stuff like that. So very simple, kind of like a container for ML code. I think the main difference from something like Docker is actually that you've got these parameters that we remember and that can have different data types that are relevant to machine learning. And so that's the projects part. And then the final part is models. So this is the one that is a little weird, but hopefully an example will make sense. So basically the idea here is whatever you use to run your code, you can produce a model in this ML model format. And then we actually ship a bunch of deployment tools with MLflow that let you deploy it in different places. If you want, it's not too difficult to write your own deployment tool as well. So the thing that's kind of unique about this format is for every model you put in, there are actually different representations of it called flavors. So for example, if you've got something like TensorFlow, there might be some tools that know how to read the TensorFlow protobuf and all the data files with the weights and actually serve a TensorFlow model. But there may be other tools that don't know how to do that. And for those tools, you can provide the Python flavor, which is just, hey, if you know how to run a Python function, just call this function and we'll apply the model. So this is a nice way to have, with these low-level flavors like Python, you can write a lot of different deployment tools that don't need to know about the internals of the model, and at the same time, you don't lose information about the ones that have that. One way to think of it is very similar to how you deploy a function on a serverless platform. It's like you don't really care how it's running it. You just want to specify something as a function. So just as an example of what that looks like, again, a model is just a folder with a bunch of files in it, and you can report it from your run as an artifact where you can report any file. And inside it, the key element we have is this ML model file that describes the different flavors for it. So for example, this here is the output if you save a TensorFlow model with the current release of MLflow. You can see we remember a little bit about how we created it. Like we remember run ID that you can use to find all the parameters, which is kind of nice. And then we've got these flavors. So the TensorFlow flavor, if you've got a tool that understands TensorFlow, maybe it knows how to compress the model, or I don't know, deploy it to like a cell phone, or who knows what it's doing, it can read these fields and figure out, okay, this is a TensorFlow model with the following properties. But then there are many tools that just want to call it and pass it some data and apply it. And for these, we have the Python function flavor, and we just give it a Python module where it calls a special function to load it and then to apply it on batches of data. So a lot of the tools we provided, like packaging the model as a Docker container or pushing it into Spark, those systems don't really care what library you use. They just care about this. And it's also really easy if you have your own favorite Python library that MLflow doesn't have any integration with. It's very easy to create a Python function flavor for it and use all our deployment tools with it as well. So that's kind of the idea of models. So that's what I wanted to go through pretty much. Any questions about this so far? Aaron is going to show this in a demo. Yeah. Yeah. Oh, it definitely is. Yeah, actually, we designed all of MLflow. You can just run on your laptop. Oh yeah, for the recording. Yeah, the question is, it seems like you have a lot of servers, tracking server, model server. Do you need to deploy lots of servers to use this? And so the answer is actually all of these things you can run just on the command line on your laptop, and you don't even need to run a server to report results. You can just save them to files. So it's designed to be really easy to use locally. Basically, you just pip install MLflow and you get all the tools. So it's designed to scale down nicely that way. Yeah. Any other questions so far? Yeah. Yeah. Absolutely. Yeah, I'll actually talk about roadmap later. So yeah, currently we only have an API in Python, and then we have REST, which I guess you could use, but it's kind of annoying to use. But yeah, the goal is to make it very easy to have these different clients, and we want to have at least Java and R as built-in ones as we go along. And we'd love to add more as well, because the interface is not that big. Mm-hmm. Yeah. You're asking. Yeah. You're asking, so the question is, would you add tracking APIs everywhere? It seems intrusive. Yeah, so the idea for that is we actually plan to have the library integrations automatically collect a bunch of metrics in the future. We haven't built that yet, so we just build the API so you can log all the stuff yourself. And then if you use projects, we automatically remember the parameters, so that's also. Yeah, it's something we want to do. It's just basically doing anything automatically. There's a risk that we record too much and stuff, and that then you get too much information. So we wanted to start with, the one where you're explicit. But it's quite, yeah, there are actually a bunch of other systems that will do it automatically, and we can do that as well. Okay, cool. So I think without further ado, Aaron is going to show a demo, and hopefully that'll make it clear how all these things work.
Cool. Thanks, Matej. And Matej will be back on stage in a moment after the demo to talk about the a roadmap coming up for MLflow, which hopefully you can help contribute to. Okay, so what I want to show here, I'm going to kind of assume that you may not know, be very familiar with machine learning, so, or you might be, so then that part will be boring. So we have a data set. This is a open data set contributed by some people in Wisconsin, I think, that's actually 5,000 wines. You can see here we have a set of features for the wines, their acidity, alcohol, pH, this kind of thing, and this notion of quality. And let me actually zoom out a little bit because we lost a little bit. Okay, and this is notion of quality, which is a median score between 3 people who were blind taste testers. So, you know, may we all aspire to be as serious data scientists as those 3 people were going through these 5,000 wines. So you can see it's a score between 1 and 10, and we're basically going to try to predict that score using the features. So by the way, this piece of code here is available in the MLflow org, like in the GitHub page. So you can see this train and the wine data set and all that. Here's like a attribution for the people who did it. So this is a very, very standard model training that we'll be doing using scikit-learn. So nothing special going on at this point. You can see we read, let me highlight it on here. You can see we read in the CSV, simple. We split it into training and test data sets. So we'll train on the training and then test on the test. And we simply drop the quality and treat all the other ones as features and use the quality as the y-axis that we'll be trying to predict. So we're going to be using this model called Elastic Net. If you're not familiar with it, this is effectively linear regression. So we're going to pick, for every feature, we're going to pick a weight and multiply it by the feature and then add them all together. And we're going to hope that ends up predicting the value. And it has this extra regularization term where we try to minimize the absolute value or the squared absolute value, some value of the weights. And so alpha is the multiplier we'll apply to all of the weights. So basically how much regularization we're going to apply. And the L1 ratio is the ratio between, like if it's 1, then we use only the L1 absolute norm, or otherwise we'll use the L2 norm if it's towards 0 or some ratio in between. So it's a pretty general purpose linear regression with extra regularization built in. So the main quantity we'll be controlling here is actually the alpha as we test it to see how much regularization we should apply. So we'll predict, so we'll train it and then we'll predict it down here, and then we'll kind of evaluate how we did, and we'll just print some stuff out. So now you can see on the screen at the top here, up here, we have like this with MLflow start run, and that says we're going to start the training process. And then down here, we have a couple extra lines, which we didn't need before, which we just log the input parameters. So we say, okay, we trained with alpha equal to this value, L1 ratio equal to this value, and the result was, root mean squared error was this, R2, and the mean absolute error was this. And then finally, we end up with this extra line here, where we log the actual model produced by scikit-learn. Okay, so this is an integration, like a convenient method really in MLflow, which allows you to take a scikit-learn method and turn it into an ML model, where you get a PyFunc, I'll show that in a second, and you get the sklearn pickled model. You don't need this in order, you can log any arbitrary model, as Matej said, but this is much more convenient if we already have an integration. So we have this for TensorFlow, we have this for Spark ML, we're adding more, please feel free to contribute your favorite. Okay, so let me show you, running this is kind of running like running anything else. So we'll just run train.py. Actually, let me run it from here. Python tutorial train.py. And I can just pass out the alpha value, let's say 0.1. And I get back a relatively high, actually, mean squared error. So that's not great. I can run it with some different alpha values. It's not changing as much as I'd like. Okay, but there I have it. So I'm just running the training, and I'll show you what happened to those log metrics and log parameters in a second. One thing you might notice, though, is I'm just using normal old Python to run this. So there's a problem with this, which is that if I am just using Python, what if I hand this code over to you? How do you know what version of all the libraries like scikit-learn, what Python version even I'm using? How can you make sure that you can reproduce this? So we have this extra piece of information that's optional. But see, it wasn't necessary, but if you want to, you can add this extra ML project information. So here we have a Conda environment, and let me just pop that open for those who aren't familiar with that. This specifies everything about my model. So for example, which NumPy, which pandas with scikit-learn version I used. You can also specify things like which Python version you use. And so that allows me anyone can just rerun the same model and have the same environment as they run it. The second thing I can specify if I want to is the entry points to my model. So here I've just specified the parameters, like what kind of types they are, what the default value are, and how to run my command. And so by specifying these, I can now, it's basically self-documenting, and I can now just have other people run it. So now if I use MLflow run tutorial, I can just point at the directory that contains an MLflow project, and I can now pass in the parameter as like alpha.1, let's say similar ones before. You'll see what it's doing is actually activates the Conda environment that I specified. So if I change the Conda environment, it would reactivate it, re-downloading the new stuff. And it looks much the same as before. Okay, great. So I've run a bunch of models. You know, I have a Conda environment that's reproducible. How do I actually use those parameters and such that I showed? So I can run this MLflow UI locally. And what this will do is it'll fire up a web server. And if my resolution went small, I could see my mouse. Okay, so here we have a cat. And then here we have a server. Great. So zooming in, we can see we have a set of runs here. And you can see it shows the different alpha values that I ran it with, as well as the metrics that were output at the end. And what I can do here is, for example, compare them. So maybe I can compare the higher alpha with this alpha. Just compare it, boop, got a table. Okay, pretty simple. I can also kind of dig into a particular run and see kind of the values and actually the model file that was produced. So this is actually, if you remember, this is just the set of flavors that we have. And so we have this pickled scikit-learn model that's actually also in the artifacts directory. And that allows us to reload it into scikit-learn. If we have scikit-learn, we can just load it back in, look at the parameters, retrain it, predict it. We also have Python function as a format. This allows tools which are agnostic, they don't really care what they're running, to deploy it or run it anywhere. And we have a couple of extra pieces of metadata like the run ID and when it was created. Okay. So that's a pretty complete story locally for how I can run and track these MLflow runs. But let's say I want to collaborate. Let's say I actually want to have multiple people working together. How do I make sure that there's like one place? Because this is all stored locally. You know, this is a local server that I'm just running. So what I want to show is, I kind of forgot to actually unset this. So let me Control-C that if I can. Great. Okay. So I'm just I have a normal EC2 machine where I've pip installed MLflow, and that's all my dependencies. And then I'm just going to call MLflow server. It's the same as UI, it's just a little bit more production ready in that it starts more threads and has a couple more parameters. So one of the parameters here is the artifact root. And so you can see this is an S3 bucket. The artifacts are stored in kind of a location that's accessible by both the client and the server, and it needs to support large data because sometimes models might be small, but sometimes the artifact data can get into the hundreds of megabytes or gigabytes or even larger space areas. So we want to have like a fast file system. But you could also use an NFS mount if you don't have S3 available, or Azure Blob Store, for example. And then you specify that you actually want to listen on all IP addresses locally, all interfaces. Okay, so we start that. And then now what I can go back and do is come here. Oops. Let's see. Yes. Okay. That was my MLflow UI. And I can just rerun this command with alpha 0. Well, sorry. First, I have to tell it that I did that. So I set the tracking URI. This is just a parameter environment variable that says MLflow demo.dev. That's the host name that I picked for my server. And so I export that. I just start running it. Maybe I pick alpha 0.1. And what this will actually do is it will report the values to my access denied. I can fix this, but I would have to show you secret information. So I will not fix this. I apologize. I forgot to rerun through this part. So imagine that worked. It's okay that it doesn't. I can run this, but you can actually see the behavior changed. That's cool. So I'll actually run it a couple more times because what's happening here is it's actually reporting the information to the remote server. And then finally, it's attempting to store the artifact in the S3 repository, which my local laptop didn't have access to because it's trying to deploy to the MLflow website instead, which is not the same AWS account. So if I go here to mlflow-demo.dev.databricks.com, I can see actually the runs. And now, if you're like, what happened with the access denied? I come in here, there's no artifact. Okay, fine. But I have all the other run information. I can see the root mean squared error is like around 3. But wait. Tomas, another member of the MLflow team, seems to have made a run a bit earlier. He picked a smaller alpha. It might have been a different version of the code, and his root mean squared error was like really, really small compared to mine. So what can I do here? Maybe I can use his run. So his run, fortunately, does have an artifact. So I'm just going to use his. Like my stuff didn't work very well. Didn't even successfully upload the artifact. Phew. Okay. So let me show you now how I can deploy this to production. So we're going to go into Spark, and we're going to do batch prediction. So this is a Databricks notebook, but that doesn't really matter. What we have here is we're going to load a different wine quality data set. Okay, it's actually the same wine quality data set, but imagine it's a different one, and we want to do scoring on it, or maybe we want to do streaming analytics. So we're going to load the CSV using a Spark data frame reader, and we'll just kind of see it show up, hopefully. All right, great. There's a nice table that shows us a similar CSV data set in a different format. We then will import MLflow in our notebook and set the tracking URI. That's the same as doing the environment variable setting. Unsurprisingly, that works. Now, to show one aspect of what we can do here, I can simply call, I have somehow already magically known what run ID to use. So I can simply import MLflow sklearn. And because I know this is a scikit-learn model, I can load it in. And so this is the run ID that Tomas ran. And so just knowing this run ID and pointing at this tracking server is sufficient for me to load that model back into scikit-learn and then run this prediction on this very specific row that I generated, and it gave an output. Okay, so this is like a way I ran this thing locally. Actually, I didn't even run it. Tomas ran it, and then I was able to load it within this notebook, which is a completely separate environment, completely separate cluster, and was able to do a prediction. Now, one thing that's even cooler, I think, is that I can now. So you'll note that this was using the scikit-learn flavor. If you want to kind of think a little bit about the flavors aspect. So I was able to pull it into scikit-learn, and I can actually do very scikit-learny things. For example, I can do model.coef, I think, which will show me the actual linear regression coefficients here. And so it's just like a normal scikit-learn thing. I can do whatever I want there. But I can also use this notion of PyFunc to load into Spark UDF. Spark doesn't care that scikit-learn. Bigger? Okay. All right. Is that big enough? I can't make it much bigger, or I can actually make it one bigger. Doop. Okay. And then higher. Okay, so Spark doesn't actually care that it's scikit-learn or not. So we'll use PyFunc here. And so we say, I pass it Spark, I pass it the name. And again, I will pass it the run ID up here. And what that will do is it will allow us to generate a Spark UDF that we can just apply. And so here, I'm going to take my input data frame. I'm going to ask it to add in a prediction column. And here, I didn't have to be so verbose about this, but I'm passing into my PyFunc UDF kind of all the parameters in the appropriate order, and then displaying that with the predicted result. And so now this is just, it'll use Spark to distribute to the executors. And we can see if we scroll to the right, a lot of columns, we have the predicted quality added to the quality. You can see it's actually pretty close. So Tomas's linear regression was actually pretty good. Cool. So that's the demo. So if you remember, we took a model from me playing around with it. We realized that my model was terrible, and Tomas had fortunately run a better one for me. And I just pulled that one down into Spark and had it run batch prediction. So it could be a very large data set. It could have been a streaming data set. It could be whatever. So thanks. Now we'll turn it back to Matej for the row mapping.
All right, so yeah, so that was the demo. Hopefully it's very easy to run those steps. If you just pip install and run the server, you can hopefully reproduce that demo, and we'll post the video so you can exactly reproduce it. So the final bit I'll talk about is a little bit of the roadmap and how to contribute to the project. So as I mentioned earlier, MLflow is still an alpha project. We definitely expect things to break, but we'd love to get your input and patches. And we also think it can be useful just to get started with for some basic stuff. And our team just made a release today, 0.21, which adds a bunch of new features. So it adds nicer TensorFlow integration, model logging and serving, which will produce a file similar to what I showed before. It adds a more robust server, the one that Aaron ran, that has multiple workers and can store stuff in S3, and also a lot of documentation and example and API improvements. But overall, we're just getting started with the project. So we have a lot of stuff in mind for what to do next. So I'll just talk about a few items on our roadmap. First of all, in terms of longer term roadmap, there's improving the current components. So for example, you saw there's this MLflow run command. There's also an API for it. You can use in Python to set up a workflow. And actually, if you look at the docs for this, it supports executing locally, and it also supports submitting your run as a job on Databricks, which is good if you have Databricks. But we actually want to make this a pluggable execution backend. So if you've got your own cluster manager and you want to make it easy to run a workflow where some steps are happening remotely, it should be pretty easy to add in a backend for this. And then you can start running lots of experiments at scale in whatever cloud environment you want. Same thing happens with the tracking store. So the server can store data in S3 and in the local file system. And we also want to support a database-based tracking store for improving scalability. We have a few updates to the models, like remembering the schema that each model needs as input. And then finally, there's easier support for multi-step workflows. So again, you can kind of call MLflow.run, but we want to let you visualize a multi-step workflow and in general be able to write things as a sequence of little steps. So that's kind of just improving the components that are there now. Beyond that, we want to add a bunch of new components. So for example, one component is for data access. If you looked closely at Aaron's demo, or even at my demo that I've done in the past, you'll see, each project kind of assumes a certain file format as input. Like in his case, it was CSV. But it's pretty annoying to have to declare a file format in advance and then convert stuff between them. So why don't we use some kind of system that can read data from many different formats and give it to you in a reasonable form, like a table or a data frame. So we actually plan to build this data API on top of the Spark data source API, and then let you load data in whatever format you expect and convert it to that, or just give you a Spark data frame or a Pandas data frame. So that's something I'm excited about, to make it really easy to share steps however each individual developed them. Hyperparameter tuning will be another component. So integrate MLflow with common hyperparameter tuning libraries, and also make it easier to launch and track many runs in parallel. It is possible already. It's just a little bit awkward. You have to create a bunch of threads and stuff like that. And we want to just make that easy to do for the common case. And then the final bit is more language and library integration. So Java and Dar are high on our list of language APIs to integrate well into. And we're also working actually on Spark and PyTorch integrations that will be built into the project. Of course, it's easy to also plug in your own code, again, as long as you can package it up, in one of the flavors we support for serving. It's easy to use whatever library you want. So we want to at least include a little example of that to show you how you can use whatever weird ML library you want and share it with users, and they don't have to know about how you built your model. So these are just some of the things that we plan to work on, but definitely let us know, talk to us if you have other ideas, or open an issue on GitHub. And if we hear good ideas, we'll definitely reprioritize. And more generally, we are developing MLflow in an open manner, and we love to get contributions from the community. So how can you contribute to it? You can submit issues and patches on GitHub. All of our development and issue tracking happens there, and there are instructions on how to run a development build and get started. You can join our mailing list. Any major kind of announcements or design discussions will be posted to the mailing list, so you can follow that. We also created a Slack channel that you can join, which is also good if you just have questions about using this. We'll probably be sitting inside it and answering stuff if you want a really quick answer. So these are just some of the ways to get started. So that's pretty much what we wanted to present. So in general, basically, the reason we're building all this is we think that these powerful workflow tools can simplify the ML lifecycle for everyone involved, both for data scientists and engineers, whether it's one person working alone or a large team pushing models to each other, and people are getting paged for different tasks that their team has to do. And basically we're inspired by the kind of tools you have for the normal software development lifecycle, where it's hard to imagine sort of living without them in a large-scale software engineering shop. MLflow is our lightweight open platform that we designed to integrate easily into existing workflows, and we'd love to get your input into it. So thanks. Yeah. So I think, yeah, we have plenty of time to answer questions. Yeah. Mm-hmm.
Go ahead.
Mm-hmm.
So the
Yeah.
UI that you showed,
Yeah.
all the rows had the same, were unique rows?
Yeah.
In terms of like the hyperparameters that are logged, or
I see.
They either were unique or they had the same hyperparameters. If I were to like tinker with different models, something like that.
Yeah, yeah.
An idea of how that would.
That's a good question. Yeah. So the question is, how does the UI scale if you have lots of distinct parameters and stuff? You could imagine a giant table. So basically the way you can tackle that is, we didn't show this, but it is actually in the code. If you do submit rows with many parameters, you will indeed get a giant sparse table, which is pretty annoying to work with. But you can also organize your runs into experiments, and you can also filter them. So you can say, I just want to view these ones. And something we are working on and have planned is actually letting you have saved filters, where even if people are logging some kind of random metrics that only make sense to them, you can get a saved view that just focuses on the one you want. So we definitely believe that, yeah, the current thing is going to hit some scaling issues at some point if a lot of people use it, just UI scaling, and we want to deal with that. Yeah. Oh, yeah. That's a great question. Yeah. So the question is, can you just add comments to a run or a parameter? Right now you can't, but I think that's a great idea. I've seen that come up a lot. Like, it would be awesome to just add some notes to it. The other thing that is maybe not super clear, but I think it's easy to allow, is like in the UI, we want to let you edit at least these comments and things later, so you can clean it up and send it to people. Yeah. Mm-hmm. Yeah. Question at the back here. Yeah. Mm-hmm. Oh, yeah. That's a good question. Yeah. So you're saying, okay, right now it seems like you still ran a bunch of different commands to train the model and deploy it and stuff. And can you imagine a click button way to do that? So we think it should be possible to build that with the API. So everything we ran as a command is also available as a Python API. And we think people will create automated workflows to do that. We may have some that are built in the future, but it's one of the things where we, we thought every team will probably have its own way. But we also, for example, like another thing related to this is just remembering what model you deploy to each platform and so on. We do want to make it possible to do all that through the API, and maybe even have a button where you can deploy it. Yeah. Yeah. Yeah, the question is evaluation. How do you do it? So yeah, right now evaluation, you can do it within each run of a project. You can report these metrics. The other thing that we'd like to do there, that is actually one of these potential kind of future components, is a tool where you can just point it to a model and give it a new evaluation set and run it on that and compute those metrics. Now, you can actually do that by hand today. Because it's easy to pull in a model using the API. It's easy to also run a project that like loads in the model and computes something. And we may make that a built-in concept. So for example, you've got a bunch of historical runs and you've got a new test data set and you want to run all of them on it. That is useful. Yeah. And that also goes with amending runs and adding new metrics and stuff. You may want to, yeah. Yeah, definitely, yeah. Yeah, it's definitely something. Yeah. And again, the other thing with all this is because it is API first, it's pretty easy to build your own scripts and tools that do this. So, and I think something we'll see, actually this happened with Spark as well. We saw people having some common workflow, like the same if statements and stuff all the time. And then when that stabilized, we could figure out a good API for it. So at the beginning, everyone kind of did it in their own way. Yeah. 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 Yeah, the question, how to track pre-processing steps. Yeah, so this gets to this the part I talked about, multi-step workflows. So using the MLflow.run API, you can run another project. So and this is one way you could create a workflow consisting of many steps, and then you can just simply swap in a different project with the same interface as your pre-processing step. And right now the UI doesn't show you the dependencies between runs, except of course you'll have parameters in there that might be a pointer to a previous run. But we also want to introduce that concept there. So when you kick off a run, we want to store the parent ID and have a nice, like, you know, thing you can expand. So that's kind of the idea there. Yeah. And a key idea of the whole project concept is you just define some parameters and then you don't care what's in the code. So someone can swap in a different step for you. Yeah. All right. Yep, thanks, and yeah, we'll, yep, and Andy as well. Yeah. So,
you know how to contribute. We're going to post the slides on the meetup, and we'll have the video hopefully posted as well. Thank you all for coming. There's lots of pizza take home, and
yep.
just flow with the flow.
Oh, okay. Yeah. Thanks.
When you say longer term growth, how long?
Oh, I mean, this is all. My guess is most of this would happen in the next.
So the recording is going to be what, in MP4?